Plants need anything other than water and the sun. Anyone have something different than that in their list or extra to that? Go ahead, Esteban. So we know they need carbon and phosphorus and also nitrogen from the soil, right? We talked about phosphates and nitrogen. Now, do plants get carbon from the soil? Where do they get it from? Someone else raise your hand and tell us where plants get carbon. In what form? What do we know that they need from the air? You got it, girl. Show it out. Also known as? Yeah, okay. Anything other besides food, water, and shelter that we need? One more we definitely need. All of you are needing it right now.
Air.
What's in the air? There we go. Where we're going today is to get a lot deeper with our answers to these questions. You guys all have a lot of fantastic thoughts about things you know about plants and animals and oxygen and carbon dioxide and water and all these things that plants and animals need and use. Today we're going to get way deeper and talk at a high school level about what's going on with photosynthesis and respiration. And to that end, could someone please read our big idea for us? Please raise your hands. Who's got it? I haven't yet heard from today. Go ahead, Anna. So today we're going to look at photosynthesis and respiration as chemical reactions. We talked about atoms and elements and chemicals before. Today we're going to dive into this idea that photosynthesis and respiration are chemical reactions, and photosynthesis and break it down. I'm going to show you how to look at a chemical equation and read it for everything it's worth. Let's start by giving our strategy. When we annotate, when we read, annotating is a way of reading in depth. So when we annotate, we're reading in depth this sentence that we're given. When we annotate something like this guy, we use these 4 steps. This is what I'm going to tell you need to do to make sure you understand what chemical reaction is. This is the reaction equation for what happens inside a chloroplast during photosynthesis. And we're going to use these 4 steps to make sure we understand everything about it. We've identified the key things this equation is telling us about. It's saying that we've got these chemicals involved, and in fact we start with, as reactants, carbon dioxide, water, and sunlight, and we end up with glucose and oxygen as products. We're going to do the exact same process with respiration, but you guys are going to help each other read this reaction and understand what's going on in respiration. First step in order to tell the story of this chemical reaction. Make sure everybody can hear you. So look and say what these are. We already know this. Everybody, what did we say this guy is? Louder so I can hear you. Okay. So Elizabeth Diaz, what is this equation telling us about what organisms start out in respiration? Definitely glucose is one thing. Is that the only thing we start with? Absolutely correct. So effectively, when you answered this question, what did we just do? Somebody else raise your hand and tell us, what did we just do? Go ahead, Trevor. Check yourself. Elizabeth, correct, and help them out. Yeah, let's remember reactants are what we start with, products are what we end up with. So if we say glucose and oxygen, and as you're writing down your answers, feel free to check those with your neighbors at your table. See if they're coming up with the same things you are as they read that equation. All right, let's go ahead and start talking through this. Myra, talk to us. What you got?
Carbon dioxide, water, and energy.
What did I just do, Carlos, in saying what we ended up with?
You did step number 3.
Which is?
Identify products.
For this one, what does that arrow mean? Go ahead, Elizabeth. So we know that a chemical reaction is occurring. That's what that arrow means. What does that mean? that a chemical reaction occurs. Someone want to add to that answer? What can we say about that? If we say that a chemical reaction is occurring, what's happening? Go ahead, Alison.
A chemical reaction is occurring
Between
between the reactants.
the reactants, and what happens then?
They oxygen products.
The reactants become the products. By doing what? Let's add one more detail to this, and we have a really, really strong answer. Go ahead, Esteban.
Atoms.
You're on the right track. The atoms are forming. What are you thinking, Guerrero? How did you have? Did you have the same thing? Changing. There we go. So those are the three parts you need in your answer. Way to work together and bring that together, guys. Nice work. Ultimately, where did this glucose come from? How was this glucose probably made? In a chemical reaction. Which one, Caesar? You had it. Using the sun's energy in what process? Yeah, there we go. So we can actually say from photosynthesis. Way to walk us through that, Caesar. Go ahead and make a prediction on what process we think we might have happening here based on our notes yesterday then. And write the equation like it tells you to do there. 1 minute. Talk about it at your tables. Help each other out. I know you didn't just pick it randomly, right? You had a reason. So what was your reason? What made you decide to say the diameter will grow instead of get smaller? What would make the diameter of the balloon grow in your opinion? Where's the air coming from? Okay, so we have more air in the bottle. Where would that be coming from? So you think the hot water is going to make the balloon get bigger? Okay. So that's one idea. We've got warm water that was getting bigger. Other thoughts? Anyone want to throw anything out there? A different hypothesis about the variable? A different reason? What do we got? Raise your hands. Every single person thought the balloon was going to get larger because of the steam from the hot water. What else do we have? Go ahead, Gilberto.
I thought it would get bigger, but not as big as it will water. Because when you put plastic with like hot water, it sort of wrinkles.
So you think maybe the hot water is actually going to cause the plastic of the balloon to shrink up?
I mean, I did it with water, but
Okay.
it works better with cold water. So I'm
So we're thinking about condensation. We're thinking about the warm air. If it heats up, it'll expand. Okay. Any other thoughts about what might happen in the cold water? Please raise your hands. Go ahead, Greg. So you think that the cold water will make the reaction happen slowly? I hear you right. Okay. How would the increase in oxygen tell us about photosynthesis?
Because the plant doesn't it decrease when it's taking photosynthesis?
Why does oxygen increase when photosynthesis is happening? Let's go back to our language from reactions yesterday. What do you know about oxygen in photosynthesis? It's a what? It's a waste what? Where does oxygen come from in photosynthesis? Or where does it go? Is it a reactant or a product?